Okay, so the next application of natural language processing, which we are going to look at, is text summarization. So, in text summarization, given a document or given multiple documents, let us say, so we want to get, without reading the different sets of documents, we want to get an idea about what is being said inside a document. So generally, we have an abstract corresponding to, say, an article. So that actually represents the gist of what is written inside the document. So can we generate such a summary using a machine? So that is what text summarization is about. Okay, so the definition is it is a process of distilling the most important information from a text to produce an abridged version for a particular task in use. Okay, so there can be different kinds of summary. Say, if it's a single document, you can have an outline, or a scientific articles, you generate an abstract, or if it is a news article, just what is most important, headline, and so on. So, different types of summaries can be generated, but the basic idea is given a large document or multiple documents, the machine should be able to uh, generate a summary which includes all the important ideas within the document. Okay. So different kinds of summarization are possible. One is single document versus multi-document summarization. So single document, as the name itself shows, that there is only a single document which is there, and we need to generate a summary from it. And it is an easier task than multi-document summarization, where you have got multiple documents. Okay, from a group of documents, we need to condense whatever is there into an abstract form. And you can also have generic versus query focus summarization. So, generic means there is no specific target or focus of the summarization, but in query focus summarization, summary is produced in response to a user query. Okay, and then there is another classification of summarization: extractive versus extractive. Extractive summary is what it does is it selects or extracts phrases or sentences from the original document in order to generate the summary. But extractive means we use different words to describe the contents of the document. You can actually read the document and generate a summary using your own words. That is easy for a human to do, but for a machine, an abstractive summary is very difficult. But so most of the summarization tasks or work which are there are in the area of extractive summarization. Now, the spec summarization systems can be divided into three subproblems. The first task is content selection, and content selection is what information is to be selected for summarizing. What are the important ideas? So, what are the important sentences to be selected and put in the summary? So, here the granularity of extraction is either a sentence or a clause. Mostly, it is the sentences which we are selecting. Okay, so content selection consists of choosing which sentences or clauses to extract in the summary. So from the big document, we select a certain set of sentences for the summary, and that is content selection. Information ordering. Now we have selected sentences. What is the order in which those sentences can be put in the summary? In the case of a single document summarization, you can just have the order in which it is given. So that does not change. So what is the order of the extracted sentences? That is information ordering. And finally, sentence realization. So, what kind of cleanup is to be performed on the sentences we generate? Sometimes you might want to drop certain parts in order to have a cleaner look for the summary. Okay, so these are the sub modules which make up the text summarization systems. So first of all, we'll look at single document summarization. So here, as we said, the extractive summary is generated only from a single document, and the unit of extraction of the granularity is at the sentence level. And in the case of content selection, of course, we need to select or choose choose or extract the sentences from the document. And in the case of information ordering, in the case of single document summarization, the order is the same as the order of sentences in the document, because uh, uh, you will have a sequence. When you look at a single document, it is written in a particular sequence or some order. So that order can be maintained in the summary also. And in sentence realization, that is after you have selected sentences and ordered it, we might have to remove some non-essential phrases or combine multiple sentences, and maybe there can be coherence issues which need to be sorted out. So these are the things which need to be done. And the important concept here is the content selection part. Content selection can be either done in an unsupervised way or a supervised way. Supervised means that there is some sort of teacher involved. So there is already data and data which tells us whether what are the sentences that are relevant. That sort of a corpus is available. Unsupervised means the system doesn't have anyone to tell it what is the right sort of relevant sentences. There is no teacher involved. And so how does it work? So first of all, we look at unsupervised content selection. So the content selection task of extracting sentences can be rated as a classification task. Okay, you can group the sentences within the document into extract worthy sentences versus not extract worthy. You can identify the set of sentences which is extract worthy, which are most relevant or salient. Okay, the simplest unsupervised algorithm is based on selecting salient or informative words. What are the important or most important words or salient sentences that you have to identify. Okay, so sentences that contain salient informative words tend to be more extract worthy or it provides more information. So how can we decide on which are the sentences which are salient? That can be based on, like we mentioned earlier, symbol word frequency can be a measure, or TF-IDF, which we already said. Another measure is log likelihood. So if it is TF-IDF, this is the measure. We have already seen this. And okay, so the other measure is log likelihood ratio, lambda. It is actually a ratio of the likelihood of a word W within the input corpus and the likelihood of it occurring in the background corpus. So that is what log likelihood ratio measures. Now here it is seen that -2 log lambda is the value. This particular value can be approximated to a chi-square distribution. So now a word appears in the input significantly more often than in the background corpus if this 2 log lambda is greater than 10.8. That is, this 10.8 is actually the chi-squared value which we get from the chi-square distribution table. Okay, and it is calculated at a particular significance level and particular degree of freedom and so on. So basically, we are trying to find the saliency of the word W, and we are finding the likelihood of the word to be occurring in the input compared to that in the background. Okay, and it is observed that the word is significantly more likely to occur in the input than in the background if the log likelihood value we compute, that is 2 log lambda, is greater than 10.8. Okay, so it is based on this value that we find the saliency of the word. So the word weight is calculated like this. It is 1, or it is considered a salient word if -2 log lambda of W is greater than 10. Otherwise, it is considered 0. So, a word is considered salient if this condition is satisfied. Similarly, for every sentence, for every word in the sentence, okay, we find the weight, and the average weight for the sentence is the average weight for all the words within the sentence. So that is how we calculate the saliency for the sentence. So from that, now what is summarization algorithm? It computes a weight for every sentence and then ranks all the sentences by their scores. So the extracted summary consists of the top ranked sentences. Okay, so that is how it works. So here, unsupervised content selection, what it does is there is some measure. It can be any of these measures. It can be a simple word frequency or TF-IDF or log likelihood ratio. Either of these measures are used to compute the saliency of words as well as sentences, and then the sentences actually are ranked, and it is the top sentences which are selected. Okay. So the algorithm is also called as centroid-based summarization because we find the centroid of the sentence and those that are close to it. basically we can think of all sentences within the document, and this top rank will be the one which are the which has a central meaning, and it comes as a center of the it can be considered the center, and all the other sentences will be as a circle. Okay, you can think of it that way. So that is why it is called as Android based summarizing. Okay, supervised method can also be there. What we saw is an unsupervised method. Supervised method, what it does is, okay, in unsupervised method we are only consider the saliency of sentences, right? Other features like position of the sentence of the document, length of the sentence, there are different features actually. The position of sentence in the document, it is found a single most extract worthy sentence in most articles is the title sentence. So depending on position of the sentence, uh, we can decide how salient it is. Similarly, there are cue phrases like in summary, in conclusion, where it is actually the very important part of a particular document will be written in association with these cue phrases. So, depending on that, there are different features like sentence length. Very short sentences are very rarely appropriate for extracting, doesn't have much information in it. So, all these features can be used and for a supervised content selection. So in the case of supervised method means there will be some training data. That is, supervised is always you have a teacher involved. Teacher in the case what we're talking about is a data where you have a large corpora involved and the corresponding uh, what the whether it is extract worthy or not. The classification label will also be given. And we need a training set of documents with set of human generated summaries. So when that is available to us, then we can use any sort of machine learning algorithms like say Bayes or decision tree or any sort of machine learning algorithm can be used for generating the summary. Okay. The last step is sentence simplification. So once the correct sentences have been extracted and ordered, order we said in the case of single document summarization is the same order as it is given in the document itself. So next step is sentence compression or sentence simplification. Say for example, in the original sentence, when it arrives sometime new year in new TV sets, the VChip will give parents a new and potentially revolutionary device to block out programs they don't want the children to see. So this is one sentence which has been selected, but we can actually simplify it to the VChip will give parents a device to block out programs they don't want the children to see. So give parents a new and potentially revolutionary. So all those extra embellishments can be actually dropped. So that is what happens in sentence simplification. Okay, so in general, what are the things you can drop? Apposites. Apposites means something is more descriptive and similar. Say, for example, Rajam, 28, an artist who was living at a time in Philadelphia. So that can be dropped. Found the inspiration in the back of city magazines. Again, attributional clauses. For example, rebels agreed to talk with government officials. International observers said Tuesday. So the main information is rebels agreed to talk with the government officials. The remaining is it is attributed to some agency. So that can be dropped. Now, prepositional phrases without named entities. Say, for example, the commercial fishing restrictions in Washington will not be lifted unless the salmon population uh, 320 increases. Okay, increases. Now the PP is to a sustainable number. That to a sustainable number, unless it has some named entities involved, it does not provide us with any extra information. For such, PPs can be dropped. And also say, for example, on the other hand, those things also do not convey any meaning. So such things can be dropped. That is what sentence simplification is. Okay. Now we move on to multi-document summarization. Multi-document summarization, as we know, the summary has to be generated from a set of documents, and actually, uh, this is still an area of research, and we can only provide a general idea about what is going on. The methods are still in the process of being refined. Okay, then the three steps involved are content selection, information ordering, and sentence realization. Okay, this is the basic architecture. The input is given, and the content selection, information ordering, and sentence realization are the steps involved. Now, in content selection, in single document summarization, we saw, okay, both supervised and unsupervised methods are found. But in multi-document summarization, supervised training sets are not available. It is not easy because it involves a lot of human work in order to actually have supervised or labeled training sets for multi-document summarization. So we only see unsupervised methods more common. Okay. Now, but the major challenge in multi-document content selection is the problem of redundancy. So here we are talking about say multiple articles on the same topic. So what happens is the same information can be repeated in all the articles, which means if we do a summarization or content selection, the same sentences can be repeated. So that is called redundancy. Multi-document can have identical sentences repeated, overlap in phrases, words, and concepts can occur. Hence, a major challenge is avoiding redundancy. Now, one method for avoiding redundancy to explicitly include a redundancy factor when choosing sentences. Okay, redundancy factor can be used. So, redundancy factor is based on similarity between candidates and sentences already in the summary. So, one example is maximal marginal relevance. So, what is done is it uses the penalty term. It provides a penalty, okay, which represents similarity between sentence S and the sentences already in the summary. Okay, so if it is very similar, then it means the penalty factor is very high. So that also has to be taken into consideration. So here MMR penalty factorization is lambda into maximum of what is the maximum similarity of the sentence which is under consideration compared to all the sentences within the summary. So you take the maximum value which and lambda is actually only a weighting factor. How much penalty you have to provide. So based on this, if there is a sentence which is very high similarity, then that sentence need not be added. So you can add a big penalizing factor. Okay, an alternative method is to apply clustering algorithm on the sentence. Clustering is a process of grouping. Okay, grouping similar items together. So what can be done is if you look at a document or multiple documents, you can for clustering you can look at pairwise similarity between sentences. Okay, so every pair of sentence in the different documents, you find out how similar they are to each other. Okay, and those sentences which are similar to each other, you group into uh, one group. So if you have 10 different ideas, after clustering, you will have 10 groups of sentences. And once that is done, from each group, we can select one sentence which represent that particular cluster. It is a clustering method. Okay, information ordering is another challenge. So in single document summarization, the original ordering of sentences cannot be can be used because there is a coherent way in which that particular document has been written. But this is not appropriate for multi-document summarization. So for news articles, what can be done is you can go for chronological ordering. But this there might be some lack of cohesion, um, uh, but chronological ordering is best in the case of news articles. But in other cases, more important factor is coherence. So you can look at the documents and then you can group them based or order them. You can generate multiple orderings such that the coherence score is highest. You identify, that is, you can have different orderings of the sentences which has already been selected, and you do a permutation combination of all the sentences and select the one with the highest cohesion. That is one method. So we don't have specific algorithms for that. Multi-document summarization is still work in progress actually. Okay.